And it's our final series, or final in the series of webinars. So we've gone from 1 all the way to grade 7 today, previous to today, and now today we're going to be able to jump in and go through the grade 8 resources and look at some of the activities that go with that. You can see there's a large pile of stuff here ready to roll, and that's what we're going to do. So my name is Brendan. I am the senior educator here at Science North. I've had my hands in developing, delivering all these webinars, and I'm excited that we get to share one last one with you today. So before I do that, though, I will take a moment just to do our landing acknowledgement and go from there. So I'm just going to share my screen very quickly. So I'll take a moment to acknowledge that Science North and Dynamic Earth are both situated on the traditional and ancestral lands of Ntikmashing, Anishinaabe, and Wampanoag First Nation in Robinson, Huron Treaty Territory. We give thanks to the Indigenous peoples who have cared for this land since time immemorial and pay respect to their traditions, ways of knowing, and acknowledge their many contributions to innovations in science, technology, engineering, and math, past and present. We also recognize the Métis Nation of Ontario for their historic and ongoing contributions, and we commit to deepening engagement, relationships, and partnerships in order to advance truth and reconciliation, honor and reflect Indigenous ways of knowing, grow economic opportunities, and collaborate with Indigenous peoples as partners in order to inspire all people to be engaged in science, with science in the world around them. So with that said, we're going to try to engage you with science today, but we'd also like you to take a moment to engage with us and share with us. So as we have teachers joining us from all over a little bit, if you would like to share where you're coming from, please do so in the chat. And if you would like to make a landing acknowledgement as well to where you are, we would love to hear that. So as we're going to our 8th of these webinars, this next piece might be something you've seen already, so I'll go fairly quick with it. But I do want to share some of our resources. So not only do we provide and offer webinars such as this, virtually or recorded, we also do in-person teacher workshops, which we have the ability to do with coding and science and all the good stuff. But we also do lots of work with students as well through our virtual learning packages, which is where we come in virtually with your students to do workshops, our high school programs, which you might be getting close to thinking about, or at least motivating your students to. We have on-site programs at Science North that fit in the curriculum, and we can also offer school outreach where we come to you. So anything that you need or anything that you're really looking for relating to teaching or relating to your students and yourselves can be found on our website, schools.sciencenorth.ca. I'll ask Brandon to post that link in there. And it's also through there that you can find our additional resources. So we have, in addition to these webinars and these list plans, we have 2 other kind of key places where you can find even more content, and that's really what it's all about, is giving you as many great resources as you can find. So we have the Science at Home section, which is you can find off of the schools.sciencenorth.ca part. And at that, during the start of the pandemic, we made a series of videos and lessons that were geared at being hands-on, quick and easy lessons that you can do with at-home material. So there's a whole series there. And for the educator resources part, this is where the bulk of our lessons live. So that not the one-offs, the ones that we're always adding, always putting new things in and up. That is where that comes from as well. So we have so many resources for you to find. So if you don't find what I'm looking for today, which I'm going to be shocked, there are other places you can find it as well, and you can check out these links to do that. Now, speaking of today, I'm going to stop sharing my screen to get myself refocused. We really geared these webinars to the new science curriculum. So I'm sure more than anything that you're aware of the changes and you are more affected by it than we are. But we did get the opportunity to take a look at that new curriculum and those changes and try to tailor some lessons and tailor some handouts and some activities to it. And that's what we're going to be looking at today, and that's what we've been looking at. So one of the our first things that we did was look at, well, where are the changes and what do we need support with? And we really identified that coding is one of the big changes that we saw added to the curriculum. So every week we've had a coding lesson to kind of work on those skills. So in our grade 7 one yesterday or 2 days ago, we had a really great coding lesson. Indigenous ways of knowing is another one that we really want to highlight. So many of our lessons have either Indigenous knowledge as its focus or included as part of it. And the third big one that we really identified as an area for support or changes or new things in the curriculum was with climate change. So the 2 lessons today really are more climate-focused lessons, and we'll be able to take a look at those and work through those. But as I say that, I'm just going to highlight kind of our schedule that we have had so far, so you can get a sense of the work that we've done and where we're going with this. So this is what we've done so far, and today is as well about melting glaciers and permafrost and the impact of oil spills. It's a very messy one. It's why I'm blue coat on to keep from making a mess everywhere. But you can see that the coding and the programming fits in a lot of different places. The 3 Sisters planning lesson that we did this week had a strong connection to Indigenous way of knowing. Today is really climate change focused. We really tried to take those 3 big changes and incorporate them into these activities and give you some ideas. That's what this is really all about, some ideas to get that working. So with that said, I'm just going to jump into our webinar goals on grade 8 today. So we have 2 pieces to it. All the things that we do have 2 lessons. We have a melting glaciers and permafrost lesson, which we'll start with before my glaciers and permafrost start to melt. And then we have an oil spills lesson as well. Each of these fit into strand A with the applications and connections to the real world. They kind of have some real world applications to them. And then the melting glaciers fits into water systems, and the impact of oil systems fits into fluids, where you can probably like flip them around or use them in both. They kind of have that broad scope for each of them. So on our website, if you've joined us, you've probably already found this. We have all the lesson plans are available to you. So we have handouts and lessons and all those things on our website. So they'll be up, if not already, they should be up by the end of this webinar so that you can go take a look. The video from today will also be up there, and we'll be able to take a look at those and kind of work through those. And that's what our goal is today, is to work through the different activities so that you can get a sense of what they look like. Our lesson plan writers all did a very good job of putting lots of good info into the lesson plan. So I'm going to share my screen really quickly, just in case you don't believe me. I know you do, but I'm just going to put this up here anyways. Right, so our lesson plans are very detailed. It has all the learning outcomes and specific expectations and intros, and all this stuff and all the different activities are all on here, and step-by-step instructions. Everything that we need to teach it is available to you. So really what these webinars are about is like, okay, let's see what that looks like. Let's see if we can get a sense of it. So we're going to go through these today, and we're going to start with our activities for the melting glaciers and permafrost one. So it's really very closely related to climate change on this one, and the fact that and changing temperatures are causing changes with our ice. So our glaciers are shrinking, but also one of the most prominent problems, especially for communities in the north, and many of which are in Inuit communities or other indigenous communities, is that the Arctic, above the Arctic Circle, a lot of that ground has permafrost in it, which is basically ice that's there year round, that's starting to melt. And because structures and buildings, all that infrastructure was built on land where we thought the ice was going to melt, and now it's melting, it's causing shifting and changes and lots of problems there. So the activities in this are really geared towards understanding some of the science behind this and how it works, and also some of the impacts. So let's work through these. I have a collection of materials that I'm just going to grab and prep for you. And we're going to start with the glacier melt activity. So for this glacier melt activity, this one's pretty straightforward, but it helps to kind of talk about how climate change is being expedited. The pause. We'll take a little break. Give me 1 second. All right. Okay, so I'm just going right into it. As you saw me make a giant mess with ice on this desk. So this one is to kind of demonstrate the difference between glaciers melting and then also how rising sea levels are affecting the rate at which glaciers melt. So I'm putting some paper towel down. Highly recommended. And then what you're going to want to do, and I don't think I froze my ice cubes quite long enough for this, which is why I am struggling a little bit with this. But what you want to do is you want to create some colored ice cubes. So you can see red was a weird choice of color. It looks too much like blood. I would recommend like any other color other than red. And the reason that we're using colored ice cubes is that it's much easier to see kind of the changes from the melting. We can see, the food coloring comes out of it a little bit better. So I'm going to put these ones back as best as I can. I'm leaning into this. My hands are going to be covered in dye. But what's the point of doing science if you're not getting a little messy? I feel like Miss Frizzle right now. Okay, so what you want to do, if I can like pop this last one out, don't want to dump it all on the table again. Oh, this is not working. All right. Maybe. I'm so glad that people get to watch me do this. It's really fun. Here we go. Okay, so we have dyed ice cubes. This is just to, someone's going to think something bad happened here. This is just the reason we use the dye, so we can see the coloring coming out of it and see kind of the rate. But what you're going to do is you're going to put water in one of the containers and not in the other, and then you would set a timer with your phone or a clock or whatever, or watch, and observe the rate that the ice melts. So what we should be observing, and this is kind of the importance of this, is as sea levels are rising, it's causing the speed that glaciers are melting to increase. So the reason for this is that air and water are both fluids. They both have molecules in there, and it's heat transfer occurs between the molecules. Now, air's molecules are more spread out; they're kind of dispersed and all over the place. Water molecules are more closely packed. So when ice is interacting with air, there are less molecules transferring heat from one to the other. But when ice is interacting with water, the molecules are more closely packed together, and so there's more interaction between them and more heat transfer that's happening between that. So what you should be looking for is kind of observing the rate that the ice is going, looking at how much red is getting in there, or blue or green or whatever color you use. Red, again, a weird choice. And then kind of looking to see like how that rate changes. We're not, actually, we probably will be able to come back to this to see the difference, but what you'll be able to observe with your students is that the more sea levels rise, the more water there is, the faster the ice cubes are going to melt. And you know what? We'll come back to this in a little bit of time just to kind of see the difference and how that works. So with that, There is a handout that goes with that one to kind of help you on that, as there are handouts that kind of help through all these. So the next piece of the puzzle is also to talk about how climate change is affecting how ice melts, whether it be glaciers or whether it be permafrost. In this case, it's in terms of something that we call the albedo effect. So the albedo effect is basically how light responds to a color, and then how that works. So anyways, effectively, I'm going to explain this as best I can using these cloths of paper. There's two ways you can do this. If you want to stay tried and true to the glacier and ice kind of analogy to it, what you would do is you would get two cloths of paper. This is felt. Felt works really nicely on this. And you would put an ice cube on each and put them on a window sill and compare the speed that they're melting. But in our case, we don't really need to do that, because the other alternative, because I don't feel like melting ice cubes all over my desk, is that you can also use thermometers with this one. You can use a lamp to see the difference as well, as long as you're using an incandescent light bulb. LEDs aren't going to really make a difference. You want something that produces some heat. But basically, you would either shine the light, put them on the windowsill, put the light bulb over top, and whether you use ice or the thermometers, put them in the same spot and observe the difference in temperatures. And what you should observe is that the darker color is going to absorb more of that heat, and the temperature is going to increase faster, and also the ice is going to melt faster as well. So the reason for that is because of the albedo effect, which basically is an explanation of how light is reflected off a surface. And what we've learned over time, as scientists have discovered, is that light is more reflective off lighter colored surfaces, your whites or grays, or really those. It's much more reflective. So we've observed that. Maybe you've observed that. As you're going to bed at night and there's snow on the ground, it seems brighter in your room. If you don't have your blinds down, because it's more reflective. That street light, the light from whatever there is more reflective off the snow and comes in. So as glaciers melt and we're getting more and more exposure to ground, which is brown and dark in color, more and more heat is getting absorbed by the ground and speeding that up as well. So it's kind of that idea that glacier melts and the melting of temperatures is happening and being sped up by climate change as well. So it's that idea that climate change is very real. It is a thing that's happening, but it's also speeding things up. So action does have to happen as a result. So we can, let's see if I can change my cameras here. And I'm not going to do this one because that's another one that takes time. It would probably take like 10, 15 minutes, but you can at least see the setup. But if I switch my camera and let's see how well this goes. Switch my camera to the overhead. We should be able to see a difference in the ice already. We're going to come here, zoom, zoom, zoom. This is a nice view of my hand. We can see that the ice cube, the size of this one, is much smaller than the ones over here. And the ones with the water are already melting more quickly than the others. We'll come back to this. We'll observe this at another time. So the last piece of this is, so we looked at two experiments that kind of show a bit of the science behind glaciers and why they're melting. So the more things melt, the more problems we kind of run into as we have rising sea levels. But also more exposure to land, which both speed up the process of things melting. It's not great, it's bad news. But let's go ahead and take a look at the last piece of this experiment. And this one has to do with permafrost. So permafrost, as I mentioned before, is the ice that is frozen into the ground, and it historically has been frozen in the ground and stays frozen. And when things become permafrost, it stays frozen throughout the year. There's no time when it thaws and refreezes, thaws and refreezes. For permafrost to be considered permafrost, it is permanently ice until climate change happens. I said that very cheerfully, like climate change is a good thing. It's not. It's really, really quite bad. So with this experiment, we're going to be looking at permafrost. And what you would do to set this up is you're going to essentially grab a tub, a Tupperware, anything. I feel this one might be a little on the large size, but for the sake of today, that's okay. That's probably a little big for what we're doing today. But essentially what you're going to be doing is you're going to be creating a layer of soil and rocks, a layer of ice, and then another layer of soil and rocks. I think I am going to use one of these smaller containers because I don't think I have enough rocks and or ice to fill this. So learn from my mistakes and be conscientious of the space that you have. So I'm going to come back to this Tupperware here, which means we're probably not going to come back to our previous experiment. But what you're going to do, you're going to grab some rocks. For the sake of the experiment, and when you're doing this, I would recommend mixing it with soil to have kind of your baseline of soil. I'm gonna switch that camera back again. So the rocks in the soil kind of will make a more firm surface and a little more compact, a little tighter, and just a better kind of experiment. So you basically are going to start with your base of rocks. Then the next piece to this is that you're going to put a layer of ice into it. So I'm going to use my ice cubes to represent my layer of ice. I'm going to put these in here. Let's do a few more. This is representing my permafrost. This ice that is kind of ingrained in the ground and is there and is part of it. And we have all this ice here. So we have this ice. It's there, and then you would take another layer of soil of rocks and add it to your container. So I'm going to use the rest of my rocks here, ignoring my beautiful pipe cleaners. Pour them in, and here we go. Okay, put these in here. I'm going to add a few more. And then basically what you want to do is to add enough rocks that we have a flat surface to work on once again. And then once that flat surface is established, you're going to build a house on it. So for the sake of argument for today, I grabbed our handy dandy Jenga blocks of science, which are really just Jenga blocks that we've created for a different activity. But that's what I'm calling them here. In our handout and our activity plan, we gave some really good tips and tricks for how you can make houses using different material. But essentially what you want to do is, once it's a flat surface, which will work better with the soil, is to build some structures, build a house as best as you can on it. So the soil will help keep that a little more flat, and put that in. And so I'm just going to build, I'm going to build some towers is what this is going to be. So here's my first sky rise. I keep saying my first sky rise. I need to get it to stay flat. So soil, it's a good helper. And then I'm going to make another one here, and then maybe another one here, soil. No. Because in my mind, it's like, oh, that sounds like it's going to be a lot of work to clean up. Which I'm sure it will be when you're in the classroom, but I think it's one of those things. If you know you're just doing this experiment once, you might as well lean into it. So anyways, we'll say this is my one tower that I've successfully been able to build. You can see it's standing really, really tall and proud on my desk. Then essentially what you're going to do is you're going to wait. You're going to see what happens. So what students should observe is that when the ice starts to melt, our surface, our layer of rocks and soil, see, I really should have done it, is also going to shift. So what happens with permafrost is the exact same idea, is that when the ice melts, everything around it is going to take up that space, and it's going to cause things to shift. So as this ice is melting, instead of my tower standing straight on a flat surface, my surface is going to start to slant and fall. And what students should observe is that over time, as the ice melts, they're going to run into problems with their structures. They're just going to start to be crooked, they're going to be unbalanced, they're going to be a thing. So this is a huge issue for many northern communities. It's one of the most daunting issues I think that they would be facing. And it's one that we don't have really obvious solutions to either. So that could be an extension or an addition to this activity, is to really have that thought process, like, well, what can we do to help with that? How would structures be built? So if you want to bring some of that into it, you can have a really healthy discussion about how we can support that and have different things in place to ensure that it's not a complete disaster. So with that said, that is this lesson. There are 3 activities: support melting glaciers, to support permafrost, and to kind of talk about how climate change is affecting both. So if you have any questions, you can go ahead and put those in the chat. And then I'm just going to place these rocks into here. I'm trying to think what I need for the next one. I might have needed that. That's all right. We'll figure it out. And then we'll take a look at the next activity. But if you have anything that you want to ask or check in, now would be the time to do it. Ask questions in the chat. Look how red my thumbs are. Well, that's really concerning. Okay, so the next activity is called the impact of oil spills. This is another one that has a very detailed lesson that will really support you with this. There's tons of great content in here. Yeah, there's lots of really great stuff that will help it through it. It includes some very real world kind of scenarios. So there is a PowerPoint that supports like a case study of an actual oil spill that happens and kind of what some of the outcome is. But really, this experiment or this activity is all about understanding how oil spills are cleaned, and then relating the different pieces to that. So there are a few different techniques that we use for cleaning oil spills, and we have to support with this. We have a handout that mentions what each of those are for the students to kind of go through. And then they're going to get the chance to kind of experiment with an oil spill as well. So to do this, what you're going to need is effectively is oil, water, and things to clean the oil and the water. Let's jump into it. Let's take a look. So the first thing that we're going to do is really just to make a combination of oil and food coloring, just to kind of see, and water as well, just to kind of get a sense of what that oil looks like and how it interacts. So I have some canola oil here, and I am going to put it in here. This is going to be my oil spill. I want to put a bunch of it in. This is the oil that I'm working with today. And then I am going to combine it with my best friend, food coloring, since I am not afraid of getting dirty a little bit. And this will just let me, when I am doing my experiments, take a look at how that works. It's kind of interesting because oil is so hydrophobic. It doesn't actually mix very well, which is kind of a neat observation. So if I stir this, I feel like this is actually probably not going to stir in. Yeah, no, it doesn't. This is actually very cool to look at. So this is a really neat way to kind of point out the properties of oil. And sorry, I wanted to change my screen view on this. This is a really neat way to look at the properties of oil. So if I put this here, you can see that my food coloring hasn't actually mixed in. If I stir it still doesn't mix in because of the hydrophobic properties of the oil. So it's not mixing in the water. If I put like this in a spoon, you can see like that's a drop of food coloring that's suspended in there. So this is the property of oil that makes it so problematic, is that it's it's not mixed in the water and it's staying on the surface, and it's like it just gets into everything. So it's super problematic. And then that's also part of why it's so detrimental to the environment, is that it kind of contaminates the water, it changes the environment, it really has long-lasting effects on that. So with that said, I want to add some water into a tub. And I'm going to take out all my materials from this one because I'm going to need some of these. I just want to put them aside. Bear with me. Okay, so what you want to do for this next piece of the experiment is that you want to get a tub and fill it with some water. In our lesson handout, we set an aluminum tin. I mean, anything that will hold water will work for this. So let's do this. Let's put this here. This is my body of water. And then I can put a popsicle stick to represent a boat or an oil tanker or whatever if I want. And then essentially what I'm going to do is I'm going to add my oil spill. And I'm going to kind of see how this interacts with the water. So I'm going to pour it in. Oh no, this is so bad. Oh God, poor ducks. I'm going to assume that's our problem here is there's lots of problems with oil spill. So this is really interesting when you look at it. Let's put this over here. You can really see the line with the food coloring. As the food coloring starts to mix in the water a little bit, you can really see where the oil is and how it compares. You can see very clearly here's my water, and here's my oil over here, and there's a very clear divide. So the food coloring not only shows the properties of the oil, but it really allows for a bit of a divide and a separation between the two. So what you want to get your students to do in this next piece is you're going to get them to try all the different materials that are listed in the handout and compare them to kind of actual things. So some of the different materials are like paper towel, cardboard, cotton balls, spoons, dish soap, and you're going to compare them to how they work. Well, this is really cool how it's pushed away from the popsicle stick. It's really interesting to see how quickly it spreads and then how also the properties of the water that keep it separate. Super neat. So some of the different things that can be used to assist with oil spills include booms, which are large barriers to keep it in small areas. So for this one, you can have students use pipe cleaners, for example, to try to keep things out of an area. So I'm going to use a pipe cleaner for this. You can use duct tape or you can use like other things. And let's say that if I had like a duck or something here and I wanted to separate it and I don't want the oil to come in, the booms are used to kind of keep the oil out. So as long as this stays on the surface level, because my oil stays on the surface, it should keep that from floating in. So my boom wasn't super buoyant in this case. So I feel like if I made this a little bit bigger and spread out its volume a little bit, I might have sunk a little bit less. But the idea here is that a boom is used to separate it. So because oil is hydrophobic, it's going to stay mostly on the surface, which is really where the biggest problem of oil comes from, is that it's a surface level thing. So it changes how sun gets in, it changes how there's feeding, changes like all these different properties. So if we can put a boom down to separate it and contain it, it makes it a little bit easier to deal with. Then other materials you can use are paper towel to represent a skimmer, or you can also use a spoon to represent a skimmer. So skimmers are, I'm gonna switch the camera. As much as I love showing you this overhead, I feel weird that I'm just talking to nothing. And I'm gonna bring this way so we can see it a little bit better. So skimmers are boats that scoop oil out of the spill. So paper towel can act as that. If you dip it in theory, it should get pieces of that oil, and now I have a very oily paper towel as part of that. Or spoons can also work as skimmers as well. So one of the pieces of this experiment or activity is to get the students to try these different techniques and kind of see what works and see like, oh yeah, I got some of this oil out. I also got a lot of the water out as well. So you want your students to test different materials and try them and see what the best way to get that oil out is. Then also to think about how it relates to those real world things. So sorbents are large, like sponge-like materials. So if you have cotton balls or actual sponges or cardboard, you can use those to absorb some of the oil. So if I put the sponge in, it should absorb some of it. So sorbents help absorb some of that oil, so I can get some of the oil out using that. And again, this is an inquiry-based activity. This is for your students to go explore and find out what they can use. Yeah, we have like a list of different materials you can use, and you want to basically try them to like see how it works to get the oil out, and then relate it to those real world kind of tools and devices. Now, for the second part of this, the next part is to kind of, okay, we've done this, we've tried to remove oil from this. How did it go? Was it a success? Was it not a success? I just have an oily, watery mess right now. And I'm sure if I put more time into it, it could get more out. But that's also part of it. Is like challenge your students to see what do you think you would do to get the oil out? Give them the materials and make that the challenge, because that is a very real world challenge, is how to get oil out of water. So if you kind of give them the tools and a bit of that know-how, they can look and experiment and do some inquiry with that. So the other thing that you can do to change up this activity is introduce dish soap to it. So dish soap is a dispersant, which basically allows us to push kind of the oils and separate them a little bit. If I add soap in here, that was so cool to see. I should have done my overhead camera for that. Let's see if I can like recapture that moment and switch the camera. Basically, dispersants have the same. Oh, that's not what I want to do. Have the same properties of the oil. So rather than kind of like gluing together, they push it away and make it much easier to empty or move or deal with the oil. So I don't know if you can see, I put the soap right in the middle, and you can actually see that all my oil is now outside on the outside of this. So let's see if we can capture that again, because that was really cool. And I'm sad that you didn't get to see this cool science. Okay, so let's pick a corner where we have lots of oil. I'm going to come over here and drop some dish soap in here. And what you can see is that the oil is kind of being pushed away from that corner. So you can actually use dispersants such as soap to kind of push away the oil and like change where it's sitting and where it is. So as I put like more in, I could in theory direct where I want the oil to go to and make it easier to remove. So as I did that, you can kind of see that the oil is pushing towards this side here. It's moving away from that edge. And now that I have it kind of contained a little bit better, it should be a little bit easier to separate and remove. So when you're doing this, you can talk about how this is beneficial and why dispersants are a good thing. And then compare it and do it again. So try it again with the booms, try it again with the skimmers, try it again with the different tools, and see how much easier it is to do that. So with that, that's kind of the experiment. It's really an oil spill in a jar, which is more or less exactly what it is, but with some really interesting science that's mixed into there and that you can incorporate and really throw in as part of it. So I'm going to switch my camera very quickly. Come back to me. Hello. If you have any questions about that activity, like I said, you can always ask us in the chat now. I'd be happy to help. You can throw us an email. Our email is readily available to you. It's educators@sciencenorth.ca. Or you can, well, that's probably really the two ways to get some support with this, is to email us or ask some questions now. But either way, we're super happy to support you with this and help you with this. Oh, and the or was that we have a really thoroughly written lesson plan by one of our staff who did a very good job with this. And so if you're just like, want to dive into this a little more, read the lesson plan. There's some great stuff. And at the end, we still want some help. That's where we can step in and support you with that. So with that said, I'm going to share my screen just to put up our QR code for our feedback. We'd love to hear from you and kind of get a sense of what you would like to see, what you've learned, what you would like to learn more of. Here it is. You can pause the video if you're watching this after the fact to kind of get a sense of what we've got. And otherwise, I want to say thank you. Thank you so much for joining us. We have, this is our last one. So if you missed any of them, go back and look at them. There's lots of great stuff. And we hope to hear from you soon. So thank you so much. Oh, and yes, thank you so much. And we wish you the best. Thank you for your patience today as I ran a little late. And hopefully we'll see you around. Have a good day.